All right, so this is the 30, 60, 90 triangles part 2. We're looking for the sides this time. So in geometry, once again, we'll repeat this. Similarity means that shapes have all the same angles and all the sides are proportional. Okay, so congruent angles and proportional sides. I'm repeating that over and over again because that's your requirement for this unit, is to know that all angles have to be the same and all sides have to be proportional. Okay, this triangle CAB is similar to, okay, so this goes CAB. So C looks like it's the 60. So it goes to E. And then A is the 30, so that'd be F. And then C, A, B. B is the 90, so that has to be D. Okay, so notice that when I do that, I'm lining up the angles. Okay, so C goes with E because they're both 60. A goes with F because they are both 30. And B goes with D because they're both 90. Okay. Okay. To prove this, we must show that the three corresponding angles in each triangle are congruent and their corresponding sides are proportional. Okay, once again, that's from this definition up here. Okay, we're just trying to count that in so you guys are very comfortable with those two parts to similarity. Okay, so in the last part, we proved that the angles were the same. Now we have to prove that the sides are proportional. Okay, to do sides in this, we're going to use this Pythagorean theorem. Okay, because triangle ABC has a right triangle, we can use the Pythagorean theorem to find the side AB. The setup equation is, so we're doing this one, a squared plus b squared equals c squared. That would be 1 squared plus, and we're calling it ab squared, equals c squared, which was 2 squared. Okay, which gives a value. Okay, so that value is 1 plus something squared equals 4. 4 minus 1 is 3. We're going to subtract 1 because we're undoing the plus. And we get 3. So the square root of 3 is AB. SQRT gives us that symbol, and put the 3 in there. Okay. Because the triangle CAB has a right angle, we can use the Pythagorean theorem also. Okay, so they both have right triangles, so that means we can use the Pythagorean theorem for both of them. Okay, the setup equation for this would be 5 squared plus, and then this one's important, you got to do the whole thing in there, so parentheses 5 square root of 3 squared is equal to, and that's EF squared. Okay, and then when we do that, that gives us 25. Plug this whole thing in your calculator, and you actually end up with 100. And so that means that EF has to be the square root of 100, which is 10. To prove their sides are proportional, we must show that there is a random or constant. Okay, the scale factor has to be constant, otherwise it's not similar, between the corresponding sides of the shapes. Okay, corresponding sides can be found by looking across from corresponding angles. Angle A corresponds to side BC, just like angle F. Angle F corresponds to DE. And side BC corresponds to side DE. So that's what that means. Angle A and angle F. And so right here, angle A is 30 and F would be 30. So they're both pointing at the same side. So that means that we can find the scale factor there. Okay, so we write 1 times our scale factor. That's to give us 5. That's the idea that we're thinking. 1 times something gives us 5. That something is called the scale factor. Okay, therefore all the scale factors have to be multiplied by 5. Okay, therefore all the scale factors are times 5, then all sides are proportional. If that's true, then they're proportional. The scale factor from A to AC to, let's see, AC is the hypotenuse, so EF is times 5, and from AB, that one's the one across from the 60, so that's DF. Notice we found a square root of 3. 5 times square root of 3 is 5 root 3. Okay, so DF. And then because all of the sides are proportional and all the angles are congruent, these triangles are similar with a scale factor of 5.